So on to session number 5, integrating Kubernetes into the Docker Enterprise platform. My name is Oliver Pomeroy, and I'm part of the solutions engineering team here at Docker. So hopefully, if you've been following along with the webinar series, you would have seen a bit of background into the Docker platform before. If you haven't and you're new, the kind of main vision or I guess North Star on what we're trying to aim and do with the Docker platform is abstract your applications away from your infrastructure, really with the mandate of any application running on any operating system, running on top of any infrastructure. Whether your application is a traditional application, a microservices-based application, or maybe some of the newer frameworks around sort of blockchain and serverless, we're trying to abstract your applications away from where they run, whether that's running on-premise, off-premise, on physical servers, or even on the edge in IoT. That's the kind of the position of the Docker platform. We've also gone through in previous webinars the 3 key pillars of the Docker platform: providing choice on what application you want to run and where you want to run it, providing agility, making it quicker and easier to roll out new software releases, and making sure security is integrated at every part of the platform. Also in the first webinar in the series, we introduced the idea of a container as a service platform, a CAS. A CAS for us is a platform that's made up of multiple components to run containers in an enterprise, including things like enterprise container runtimes, container orchestrators, as well as management tools and container registries. All of that kind of wrapped together, we class as a container as a service, or a CAS. And we also introduced the idea that Docker Enterprise, the Docker Enterprise Container Platform, is the kind of is the perfect CAS for you to use, both including Docker Swarm and including Kubernetes at the orchestration layer, supporting both Linux and Windows workloads at the container runtime level, and then providing management tools like the Universal Control Plane and the Docker Trusted Registry. We've already talked about the fact that Docker Enterprise Container Platform can run on any infrastructure, whether that's physical, virtual, on-premise or off-premise. We honestly don't mind. We come at this with a choice perspective. So in this particular webinar, we're going to focus and kind of narrow in on the Universal Control Plane and how the Universal Control Plane manages Kubernetes on your behalf. Kubernetes is a key part of our platform. It comes installed out of the box, and we are actually a certified Kubernetes distribution. So we've passed all of the relevant tests to come out as a certified Kubernetes distribution. So you know that when you start to deploy and develop Kubernetes workloads as part of Docker Enterprise, you're not getting locked in. We are conforming to the open standards. We are conforming to the kind of industry and open source project. One thing I did want to highlight, this actually all came around from an announcement in DockerCon in October 2017. So we here in Docker have been embracing both Docker Swarm and Kubernetes in all of our platforms now for just over 18 months. Whether that's including Kubernetes as part of our Community Edition products in the desktop, or shipping Kubernetes as a key orchestrator inside of our container orchestration platform, Docker Enterprise. So first off, and let's kind of go through how Kubernetes is integrated into Docker Enterprise and how you get to take advantage of it when you want to start deploying your workloads. First thing, we're going to kind of look at the container platform lifecycle. Kubernetes has quite a reputation on the complexity to install, kind of grow your clusters, upgrade your clusters, and then back up your clusters. And we in Docker have done a really good job at simplifying all of that for you, making Kubernetes really, really easy to manage on top of Docker Enterprise. We've seen many cases out there in the press that poorly configured or poorly installed Kubernetes platforms have led to vulnerabilities, whether that's people exposing Kubernetes dashboards or Kubernetes API servers publicly, whether they've not enabled TLS between all of their infrastructure, or whether they've failed as part of an upgrade and ended up bringing down workloads, we here as part of Docker Enterprise take all of the stress for those kind of 4 key pillars of the lifecycle away for you. So let's have a look at first how we handle a Kubernetes installation as part of Docker Enterprise. First off, I will say is Kubernetes is installed by default in all Docker Enterprise deployments. The universal control plane is the particular piece that will install and manage the lifecycle Kubernetes from that management layer. One of the key things and one of the key advantages of our platform is that everything in the universal control plane runs as containers. Whether you're talking about the management tools and the management user interfaces, or you're actually talking about the Kubernetes components themselves, they will all run as containers on top of a Docker engine. Therefore, all you need is a Docker engine, a bootstrap container to start it all off, and then everything happens kind of automatically. There is no kind of pain, there is no kind of Kubernetes the hard way here. All you need to do is install the Docker engine, run the bootstrap container, and then everything will be deployed for you. And when I talk about everything here, I'm talking around things like the Kubernetes control plane, the Kubernetes networking stack, things like a role-based access control engine, and as well as that, the key value store where all of the data from Kubernetes is stored. So therefore, once you install Docker Enterprise, all of these bits are deployed for you and managed by a UCP. You don't have to do any of the pain that is involved in a manual installation of Kubernetes. We automate all of that for you. So I'm going to try and do kind of an interactive session as we go through the webinar today, and I'm actually going to start off a Docker installation, a Docker Enterprise installation, and keep checking back in as we work through the content. So I'm actually going to do this particular demonstration on Microsoft Azure. As we talked about, we are absolutely agnostic at the infrastructure layer. You can run on whatever platform you'd like. But in this particular demonstration, I'm going to build out and show the lifecycle of Kubernetes running on Azure. You can see inside of my environment here that I have a number of virtual machines. Some of them are called managers, some of them are called workers. In reality, they're just virtual machines running a Linux operating system. So I've jumped into one of my virtual machines, the first manager. I've patched my virtual machine, and I've installed the Docker engine. So a quick version of Docker version, quick run of Docker version, sorry, shows that I have the Docker engine installed. That is all the prerequisites required to install our container platform. You don't need any large Ansible scripts here. All you need is a virtual machine and the Docker engine. To then start off the process of a Kubernetes installation, which in reality is just a Docker Enterprise installation, all we need to do, going back to this diagram, is start off the bootstrapper container, and the rest of it kind of happens automatically. So to start off the bootstrapper container, all we need to do is a Docker run command. Now, I've just preloaded it inside of this shell script just so I don't do any typos during the demonstration, but all you can see that it's doing is a Docker container run, starting up UCP as a container image, and there we go. All of this is now part of the bootstrapper container. So I want to use an install and pass in a few variables like a password and an IP address. So that one line command will install our whole platform. It's that simple because everything runs in containers. So I'll start that off, and we should now start to see the container platform being deployed, and it's going to go through its various checks before it starts to bring up the platform. I did want to kind of just prove the point that everything's running in containers, and so if I did a kind of show me all the containers that are running, you can start to see here that behind the scenes, the UCP bootstrapper is verifying that this virtual machine is ready to have an installation, and then we'll start to deploy for me. That's it. That's as simple as it is to install Docker Enterprise and to install Kubernetes as part of our platform. This is going to take a couple of minutes to run, so I'll check back into it in a minute or two. So the next part of the life cycle around Kubernetes as part of Docker Enterprise is how you grow your cluster. You may spend a lot of time today kind of working on scripting to do the installation of your first platform. However, if it's complex to grow, you're going to be quite scared to start to add new workloads onto it. That is not a problem as part of Docker Enterprise. As part of Docker Enterprise, you can seamlessly grow from one manager node to a fully resilient 3 or 5 manager node deployment just with one line command. And you can add as many workers as you'd like. Once again, the same one line command can add workers in. And this is all possible because we are actually running everything as part of Kubernetes in containers, and we're running those containers on top of a Docker Swarm. So Docker Swarm has a really, really good way at managing clusters. It's secure by default. It has TLS enabled. It has everything stored encrypted in a wrapped store on the manager nodes. So we're able to take advantage of the simplicity of Docker Swarm to grow our Kubernetes clusters. All we will end up doing is kind of telling a new virtual machine, please join our cluster. At that point, we'll add it in. We'll start up a UCP agent, and that UCP agent will configure everything for us. It will configure TLS, it will start the Kubernetes kubelet, and it will bring up the Kubernetes networking components. Everything is kind of automated for you. So these are kind of the 2 line commands you'll need. To join manager nodes, it's a simple Docker Swarm join. To join worker nodes, once again, it's a simple Docker Swarm join. Okay, let's check on how my installation is doing and see if we can grow our new cluster. Okay, so just jumping back in, you can see that the installation is just about finished. Yep, so if I open up the web browser, navigate to my IP address, a quick refresh, and perfect, we can now see that the Docker Enterprise installation has finished. This is not pre-recorded, this is all being done live. You saw me kind of start the Bootstrapper container and then install Docker Enterprise. It was that quick and easy. Quickly logging into the platform and uploading a license key. You can see that I'm now into my Docker Enterprise environment. You can see straight off the bat that I have one manager node running, and I have both Kubernetes and Swarm as available orchestrators. I want to kind of show how easy it is to expand a cluster as part of Docker Enterprise. So here you can see that I have one virtual machine running as a manager node. I want to make a highly available deployment. How quickly and easily can I do that? Well, fortunately, I have 2 more manager virtual machines sat here with the Docker engine installed. Perfect, they passed the prerequisite. It's a virtual machine, it has the Docker engine installed, it's now ready to be part of my cluster. So let's click on Add Node. I want to use a Linux virtual machine and I want them to be manager nodes. Copy the string and paste it into these 2 windows. Great. It's as simple as that. You will now find all of the components for Kubernetes are going to start to be deployed onto those 2 virtual machines as containers. So I've gone from nothing to a Kubernetes cluster to now, hopefully with a quick refresh, you'll start to see that it's a fully resilient Kubernetes cluster as managers 2 and 3 start to spin up. Once again, no complex scripting required here. I haven't had to go and learn a configuration management tool or require anything else. It's simple, everything runs in containers. Okay, now I want somewhere to run my Kubernetes workloads. How do I add workers to this cluster? Once again, it's a pretty simple string. We saw it before, so just add the node, Linux, and worker. And once again, I have a few things staged. So I have 3 virtual machines sat here waiting to go. all of them with the Docker engine installed. Therefore, all I need to do to add them to my cluster again is Docker Swarm join. And remember, these are Kubernetes worker nodes. They are not Swarm worker nodes. We are just using Swarm to manage the cluster lifecycle. Okay, so give that a quick refresh, and you should see that all the nodes are now in, and they're currently working through their installation. So hopefully, when I check back in a few minutes, I should have 6 nodes in my cluster. Okay, so next on the Kubernetes lifecycle thing. So you saw me install the platform from scratch in a couple of minutes. You saw me take a single node cluster to a highly available cluster, and then from a highly available cluster with no workers to a highly available cluster with 3 workers. The next kind of question is, well, Kubernetes is great, but Kubernetes is actually quite a fast-paced, moving open source project. As part of Docker Enterprise, how do we handle upgrading Kubernetes? Because I realize that it has releases quite often. Well, Docker Enterprise has a patch release every month, and it has major releases every 6 months. Kubernetes may be patched as part of a Docker Enterprise patch release, depending on how they sync up. But every time Docker Enterprise has a major release, we will upgrade Kubernetes as part of that. So you kind of see Kubernetes has releases today 3 times a year. We will pick up the latest major release of Kubernetes every time we do a Docker Enterprise major release. But then the question becomes, well, how do I actually pull down and upgrade my cluster? Like, all that's okay, but what's the process? Like, is it very disruptive to upgrade Kubernetes as part of Docker Enterprise? And the answer to that question is no. Because everything runs in containers, we've all seen how easy it is to stop old containers and start new containers. We were able to take that same approach with Kubernetes. We will bring back up our bootstrapper. Our bootstrapper will talk to our agent and say, hey, new version is available. Please roll out the new version to the whole cluster. And that's it. Simple as that. The rest of the cluster will upgrade itself. And there you're upgrading the universal control plane, and you're upgrading Kubernetes. We have a similar process when it comes to actually backing up your cluster. We realize that Kubernetes is quite a complex thing to try and understand how to secure and how to back up. In Docker Enterprise, we take away all of that complexity. Docker Enterprise manages the etcd key value store, which is kind of like the brains, well, not really the brains, but kind of where all the data lives from Kubernetes. Docker Enterprise handles that key value store and handles making it a highly available deployment. Docker Enterprise also handles backing up etcd. So as part of Docker Enterprise, if you want to back up your Kubernetes cluster, all we need to do, bring back up our bootstrapper container. Instead of saying UCP install or UCP upgrade, we're just going to do UCP backup, and it will take a snapshot for us of etcd. That snapshot will be then saved locally for you to be able to restore your cluster in case anything goes wrong. One thing I will say, this is only backing up etcd. We're not backing up workloads. If you have workload data stored in external storage systems, we won't be backing those up. We're only kind of backing up the Kubernetes components as part of etcd. Okay, so let's see how my cluster's doing. Quick refresh. Perfect, everything looks green. So I've gone from having nothing to having a single manager, then from a single manager to a highly available free manager deployment. And then from a highly available free manager deployment, I then added some worker nodes. And you can see here, the type of the worker nodes are Kubernetes. I'm ready to start to schedule pods. I'm ready to start to bring up my workloads. How does an upgrade work in this environment? Well, if I quickly about, you can actually see that we're running Kubernetes 1.11.7 in this particular version of UCP. As this helpful banner has told me, there's a new update available. So let's see how we can upgrade the whole cluster very, very quickly. Going back to my first manager node, all we need to do is bring back up our bootstrapper container, so Docker container run, UCP, and upgrade, and then the whole cluster will be upgraded for us. It's going to quickly give me a quick, are you sure you want to do this? Which is a very helpful yes or no. And that's it. We have now, we will now go through the process of upgrading UCP. I haven't had to do anything on all of those virtual machines. I don't have to go around the houses on every single virtual machine and patch them. I don't have to write a big config management script to handle Kubernetes anymore. All of that pain has been taken away by Docker Enterprise and the Universal Control Plane. It says it can take up to 15 minutes to do the installation. I expect it's going to be a lot quicker than that because there's no because it's only a small environment. But we'll check back in a couple of minutes to see what state it looks like. Okay, so hopefully at that point you've shown how easy it is to handle the lifecycle of Kubernetes as part of Docker Enterprise. Now we're going to kind of look at some of the other things that Docker Enterprise adds on and kind of as part of a Kubernetes deployment. Firstly, looking at security and multi-tenancy. One of the things that's quite a pain when rolling out your Kubernetes environments is handling user management. Trying to understand what users can have access to Kubernetes and what users can't. And then trying to understand how that can integrate into your existing tooling and processes. Well, Docker Enterprise dramatically simplifies that process. The Universal Control Plane runs a role-based access control engine. The role-based access control engine can integrate into LDAP, into Active Directory, or even into some SAML v2 providers such as Okta or Ping Federate. So therefore, you don't have to worry about changing your business processes when you bring on a Kubernetes platform. You integrate Kubernetes with Active Directory, and then as you configure and as users and teams come and go inside of your enterprise, they are being seamlessly synchronized to Docker. At the same time, we've made it very, very easy for users to integrate with existing tooling with Kubernetes through something called a UCP client bundle. And we'll take a little bit more look at the UCP client bundle in a demo shortly. And one thing I will say, this auth-n component, this user management, is across all endpoints. Everything is secured from the UCP user interface to the UCP API, the Kubernetes API, the Kubernetes CLI, as well as the Docker Trusted Registry. Once you integrate Docker Enterprise with LDAP or Active Directory, you have security across all of the touch points of your container platform. We also work hard to make it really, really easy to actually handle the auth-z component, providing the granular role-based access control on each Kubernetes object. Now, Kubernetes, if you may or may not know, has a role-based access control API, and we integrate seamlessly into that. So when you start to create roles, which kind of tell you what you can do, to role bindings, which match a role to a user, once you create those in Kubernetes or try and port across existing deployments or ISV software releases onto Docker Enterprise, all of those Kubernetes APIs will seamlessly work and drive UCP. You don't have to worry about rewriting anything when bringing Kubernetes objects onto our platform. At the same time, we can start to group Kubernetes resources to kind of create a multi-tenant platform through namespaces, which are kind of like a logical separation of pods and volumes and secrets and so on. Or you can group resources via a physical means by saying that application team has access to those virtual machines. and the next application team has access to those virtual machines, kind of doing a physical grouping of resources. Both logical grouping with namespaces or physical grouping with worker nodes can be seamlessly integrated into the RBAC engine, so you can kind of see how user management works. So let's have a look at a quick demonstration. Here I have, actually, the first thing I'll do, I'll quickly check on the progress of my upgrade. Success, the upgrade is done. Quick refresh of the dashboard. Perfect, we are now on the latest version of the control plane, and a quick look. Oh, cool, we're on 11.8, we're on the latest version of the 1.11 branch of Kubernetes. It was that simple to upgrade Kubernetes as part of this platform. Okay, having a look at user management, I'm actually going to switch to a separate cluster. And in this separate cluster, I've integrated it with an LDAP provider. Quick look, log in. You can just see here that I have some sample users and sample groups defined inside of LDAP. I have integrated the control plane and therefore Kubernetes with LDAP. So as users and groups leave your organization, you don't have to worry about user management of Kubernetes. So I have a user here, it's called demo person. So let's log in as the demo person. Type their password right. And so straight away you can see that the control plane's authenticated through LDAP. And let's try and deploy something as the demo person. Well, to do so, I'm actually going to use a client bundle. Now, a client bundle is a set of certificates and keys that UCP manage that will authenticate every single user with the cluster. So you don't have to worry about managing usernames and passwords of Kubernetes anymore. UCP handles all of that for you with a client bundle. So I've jumped to a fourth command prompt, and I'm going to copy across that client bundle I just downloaded. You can see it's a zip file, so I'm going to unzip it. You can see now that I have a set of certificates and keys which are unique to that user. We will use these certificates and keys to authenticate against Kubernetes. So if I do kubectl, which is the Kubernetes command line, I'm going to just quickly sideload in that config, which you can see is here as part of a client bundle, and get nodes. Perfect, you can see that the demo person is able to talk to Kubernetes. I have given the demo person the rights to view nodes, but I've not given him the rights to view pods. If he tries to access pods, he can't. That's part of granular role-based access control. So let's see how I would give the demo person rights. I'm an administrator here. So I'm going to go to grants. I'm going to create a role binding. I'm not actually going to do an individual user. Individual users come and go. I'm actually going to do a team. So I'm going to say anybody who's in the developers team, which fortunately, quick look at LDAP, the demo person is, has access to a default namespace, the logical grouping of resources, with a view pods role. So everybody who's in the developer team in LDAP can have view pods access to these logical resources. Simple create. I've now got myself a new bit of authorization, running the same command. Bang, there we go. I haven't had to download a new client bundle. You can see here that an administrator can take and remove privileges very, very quickly from individual users or teams. And that user's identity is handled via client bundles, and user's identity is seamlessly integrated into LDAP. Okay, keep going. So what else do we do on a security side inside of Kubernetes for Docker Enterprise? Firstly, we handle user management, but we also secure the networking stack. Now, Docker Enterprise provides a batteries included but swappable Kubernetes networking stack, and we leverage the Kubernetes Container Networking Interface, or CNI. Docker are working closely with Tegira. Tegira are a company that make Project Calico. Calico is by far one of the most popular, or if not the most popular, but one of the most popular Kubernetes networking stacks. And as part of Docker Enterprise, we will handle the lifecycle of Calico for you by installing it via that Bootstrapper container as you saw, and also handling upgrades and support. You get fully supported for the open source Calico project as part of Docker Enterprise. And Calico has really, really good security features. By default, for example, all Kubernetes pods can communicate with each other. If they're on the same virtual machine, if they're on different virtual machines, if they're in the same namespace or in different namespaces, it doesn't make a difference. Kubernetes operates kind of like a flat network at the beginning. But through Project Calico inside of Docker Enterprise, we can actually start to create network policies. Now, network policies can be deployed via administrators or operators, and they can restrict what pods can communicate with other pods. They basically create kind of firewall rules that reject communication going into a pod. So therefore, you can have two tenants, application team 1 in namespace 1 and application team 2 in namespace 2, and you can prevent any network traffic kind of going between those pods. Or for example, let's say you had two pods in the same namespace and you wanted to for security reasons, stop them communicating. I don't know, you wanted to stop the front end talking to the back end directly. You kind of wanted the front end to go to the middle, the message bus and then back out. Then you can provide a network policy rule to stop two pods talking to each other. All of that is possible as part of Docker Enterprise with our seamlessly integrated Calico deployment. We also kind of go one layer further on this networking security side, and that's with networking encryption. We all know that we're starting to use more and more shared infrastructure, but how do you protect your traffic when running across this shared infrastructure? Well, we can do that with networking encryption. And networking encryption will encrypt the Calico overlays between virtual machines. So for example, if a pod on worker number 1 wants to talk to a pod on worker number 2, as part of Docker Enterprise, we can encrypt that traffic so that anybody who's on the infrastructure side monitoring that communication will be unable to see what's going on inside. Because we do the encryption at the virtual machine layer, all of the tenants and users don't need to worry about configuring anything special inside of their workloads. They can just happily deploy their workloads as they are, and the encryption happens seamless, without their knowledge. And just kind of for those people that are curious, the traffic is encrypted in the kernel using IPsec capabilities of Linux. So there I just kind of went through some of the multi-tenancy features and security features that you get as part of Kubernetes on Docker Enterprise. So next, I'm going to spend a couple of minutes talking around application deployments. If you were on one of the previous webinars, you would have seen this slide before. But this particular slide talks around how inside of Docker Enterprise, we use Compose to abstract application definition away from the kind of orchestrator that you use. If you're a developer today and you're developing applications on Docker Compose locally, you don't have to worry about converting that into Kubernetes config files or Kubernetes manifest files. The same Docker Compose files that developers are really, really friendly with can now be used to deploy your workloads onto Kubernetes. Basically, when you write a Docker Compose file now and try and deploy it in Docker Enterprise, you simply say, hey, this Compose file is going to be on Swarm, or this Compose file is going to be on Kubernetes. You don't have to worry about translating it. You don't have to worry about trying to understand, well, a service in Docker container is this, and a service in Kubernetes is that. We handle all of the seamless migration of a Compose file to Kubernetes for you. So therefore, you don't have to worry about kind of how you write your applications. Developers can carry on using the tools that they know and love today, and roll and kind of use that on top of Kubernetes inside of Docker Enterprise. One thing I will say, and one of the big announcements from the December DockerCon conference in Barcelona, is that Docker Compose on Kubernetes is completely open source. If you want to have a look at this and see how we're doing it, or maybe even deploy Docker Compose on Kubernetes on a alternative Kubernetes platform, you absolutely can. We've open sourced all of that goodness on converting Compose to Kubernetes. One thing I will say is, as kind of part of this platform, if you did want to deploy applications through alternative definitions, so you wanted to use Helm charts, for example, or Kubernetes operators, because we are just deploying an upstream Kubernetes distribution, we don't have a very opinionated fork, then absolutely, you can use whatever application definition frameworks that you want. You could easily deploy Tiller on top of Kubernetes and start using Helm charts straight away. Or if you wanted to start to use the operator framework, you could do too. We are not restricting you on how you want to deploy applications on our platform. However, we just know today that a lot of developers have a lot of their applications already defined in Docker Compose, and we want to make it seamlessly easy for a developer to pick up their application that they're working on in development and drop it onto production on Docker Enterprise. So hopefully there you've seen some of the key components of Kubernetes running in Docker Enterprise. And this is all part of the wider container platform. We have a Docker Desktop Enterprise, which I've shown in some of the previous webinars as a local development environment to create containers locally. And Docker Desktop Enterprise fully deploys and manages Kubernetes for you as well. So if you wanted to create Kubernetes objects as part of your local development environment, you can do so in Docker Desktop. Once you've created your assets on Docker Desktop, you can seamlessly ship those to either the Docker Hub, which is a public repository, or to an enterprise's Docker Trusted Registry. And a Docker Trusted Registry is obviously an on-premise or self-hosted enterprise container registry. And then you can run your applications on the universal control plane. And there today, we looked in detail at the universal control plane and running Kubernetes on top of or within the universal control plane. For those interested, Forrester recently released a new wave for container platforms, and you can find Docker as a leader in this space, and the link below will take you directly to that report. Well, that's it. That's everything from myself today. So thank you very much for listening, and goodbye.
Thank you, Oliver. We will now open things up for Q&A. We have Gary Hutchins, Docker Senior Solutions Engineer, on hand to take your questions. So if you haven't already, please drop those in the questions panel, and we'll have Gary address some of those right now. Gary, do we have any questions rolling in that you can share?
Sure, we actually have a fair amount, and I think I highlighted a couple of them that I kind of wanted to go over again. So the question came up is, what is the real advantage of executing Kubernetes over Docker Swarm? And I think that conversation comes up a lot in this construct. And the way that Docker proper looks at it is it's whatever's best for the users and whatever best for the organization. We support both of them fully from the EE platform, and we support both of them as first-class citizens. So some tooling, some methodology is better for Swarm. other tooling and methodology is better for Kubernetes. And so that's why we offer both of those solutions right out of the package. And I think that's a great construct. Another one comes down to, can I get a trial version of Docker EE and UCP? Yes, you can. There's a fully trial version available on the website. It's good for 30 days. It gives you 20 nodes to play with. And so feel free to go out and do that. I would spend time looking at that. There also is a great web page that we have, is success.docker.com, that has a lot of good detail around that. The question came up as more questions are popping up here. The word pod is used a lot. Is this term interchangeable with container? Yes, it is. Actually, a pod is a running container. It's a Kubernetes construct. So a pod is basically a container. Each member of the team has to get a license of EE in order to use the capabilities of EE. No, the license is at the cluster level. It doesn't matter how many users that you have access to that EE platform. So we have no user limitation. We are basically licensed on the resource of the nodes. So if you have a very large node, we license it at the resource level, but we do not license it at the number of users, and we do not license it on the number of containers running in the environment. Can UCP connect with cloud controller managers? No, we are our own management plane. So if you're using like EKS and AKS that have their own control or management plane, yeah, currently UCP does not control those because we don't have access to those pieces. If using Docker machine to install UCP, how to create the specific IP. Normally, the way you would deploy Docker EE, a platform, is kind of get the infrastructure set up and ready to go. And then once the infrastructure is set up and ready to go, then you kind of deploy Docker on top of it. I saw a great question earlier is from a deployment model, everything we do and everything you saw today in the presentation are containers that run inside the Docker engine. So once you install the enterprise Docker supported engine on the nodes, everything is now a container construct. So deploying UCP is a Docker run command to deploy UCP. Deploying Kubernetes is a Docker run command in executing those things. And those nodes actually allocate that and go through and execute the services. So we try to keep the OS functionality as barely or to a bare minimum as possible, which kind of leverages into another quick question is, can I run this on hardened operating systems? And the answer is absolutely yes. And most of our enterprise customers do run this on hardened operating systems. Can I integrate all the tools and functions with my pipeline? Yes, absolutely. That's one of the benefits of us. We are very open in how users connect to us. We are API termination points. So we integrate into Git, we integrate into Visual Studio, we integrate into Maven, we integrate into a lot of tooling constructs. And you saw earlier around the client bundle pieces, allowing you to connect those services from those pieces into our tooling methodology is very simple and straightforward. Let's see what else as we go through here. These are all great questions. How can we learn about Docker Enterprise in our lab? At success.docker.com. That one is a great tooling piece. And I think, let's see, as I go through these, they are coming up pretty quick. Again, yes, you can run both Swarm and Kubernetes in parallel. And again, the reason you pick either one is based upon your tooling, based upon developers' familiarity with it, based upon whatever methodology internally that you're leveraging. Again, Docker EE treats both of them as first-class citizens. So away you go. What are the benefits over Kubernetes versus OpenShift? I think both of them offer solutions. We try to offer a non-opinionated construct. So again, tying into more tooling methodology, upstream developers pipeline, the desktop experience, the developer experience, going all the way to execution into production. They're both great solutions, but I think we have a great holistic end-to-end story around that. Is there a need a UCP agent on each and every cluster node? Yes, you do need a UCP agent on each and every cluster node, but that agent is installed when you do a cluster join. So it's nothing that you have to basically do. So when you actually do a Docker node join, the UCP agent gets pulled off the UCP manager, runs it as a container onside that node, and joins it to the cluster. So the idea is that you're not having to manage it on a day-to-day basis. You're not having to deal with it in a normal operational construct. But yes, there is a UCP agent on every node in the cluster. That's how we communicate health checks back up to the manager plane, the manager framework, and that's how we know about node health, node utilization, all those type of things. But you don't have to actually install an agent on each node. Again, each node just installs the Docker engine, and everything else is a container that runs inside of that. Let's see, what else we got here? Yes, Docker EE supports Windows containers in production environments. We do support that. Right now, we don't support it in Kubernetes. That is a swarm construct. But as Kubernetes gets more production ready, that will be a first-class citizen as well, as soon as that becomes widely adopted. As you showed an example of joining master and worker nodes by using swarm token, is that means that UCP agents connect with underlying Calico and K8s need to connect with UCP agents to communicate with pods? No. Once the swarm join is executed and that node trust is established, then what happens is that node gets basically two control planes on it. It gets a swarm control plane and a Kubernetes control plane. And so then you can go into the UCP and say, hey, this node is a swarm node, a Kubernetes node, or a mixed node. If you make it only a Kubernetes node, we actually remove the swarm functions off of that node and completely isolate it to a Kubernetes construct. So you can actually manage it that way. And then the UCP agent is basically the connector piece on top of that. How do I restrict access between containers in one pod to containers in another pod? That is a container question, but that's going to show you a good thing. You would typically create namespace isolation, or you would typically create different services with different deployment sets. Those are become programmatic, and that's one of the reasons why we chose Calico. Is Calico has a bunch of CNI advantages that allow you to do things like container pod isolation. That may or may not be there in other CNIs. You do not need to pay for Docker Desktop. There's a Docker Desktop CE version that you can just go ahead and download, and away you go. And I think I captured most of them.
And we do, again, thank you guys for submitting these questions and being so interactive today. It's great. It makes it a much more interesting session. So we do appreciate all those questions. I'm looking through and I don't see, but again, we are keeping a copy of all these questions. We have one more webinar in this series, and then after the webinar, we are going to do a blog, and we'll follow up, with some of the highlights, some of these questions from today and over the last few sessions. So with that, then I will once again thanks Oliver for his time today presenting, and of course, thank you, Gary, for tackling the Q&A for us. And this will conclude our webinar. Just a reminder that today's session was recorded, and you will receive a follow-up email to view this recording within the next few days. Thank you again for joining us and hope to see you at next week's webinar. Thank you, everyone. Have a terrific day.